Hello friends, as you know, lockdown is going on and we all are studying online only. So for this solution only, here I am with the ICSE class 10th chemistry subject, chapter 4, and we are following concise chemistry. So page number 64. This is I am telling you why, because later on after watching this video you can follow your book also. As you know, this is a time you can improve your reading habit, because books are your best friends at present, because at this lockdown period you are not going to the school. So see your best friend in your books. So you can adopt the habit of going through your books and make notes and improve your reading habits. So let us begin this chapter. To begin this chapter, first of all, let me tell you what is the syllabus we are going to cover up in this chapter. The first topic we are going to cover, the action of sodium hydroxide and ammonium hydroxide and sodium hydroxide on solution of salts. Which salts will take? Calcium, iron, copper, zinc and lead. And the second topic we will discuss in this chapter is special action of ammonium hydroxide. You know the formula of ammonium hydroxide is NH4OH on solutions of copper salt and sodium hydroxide, that is NaOH, on ammonium salts. Also, we will discuss color of salts and its solution. And the fourth topic we will discuss is action of addition of sodium hydroxide, also ammonium hydroxide, to the solution. Which solution we are going to take? As I discussed earlier, that is calcium, iron, copper, zinc and lead salts. So we will add these sodium hydroxide and ammonium hydroxide separately, drop by drop and in excess. Then we will see the formation of color of hydroxide precipitated, that is when the reaction will take place, the product will form. You know, now when reactant react and we get a product. So let us take, we are taking a salt, any salt, a salt we are taking and we are adding NaOH. Of course, the product formed will be hydroxide. It will form any hydroxide formation will be there. So there will be some hydroxide will form and we will see the precipitates formed, highlighted with the help of the equation. One by one we will take the equation. So this is all about the syllabus we are going to study in this chapter. So let us begin the chapter. So in the introduction, so what is analysis? Analysis is determination of chemical components in a given sample. And when we do analysis, there are two types of analysis in the chemistry we do. First is qualitative analysis and second is quantitative analysis. First is qualitative, another is quantitative analysis. What is qualitative analysis? In this qualitative analysis, we involve the identification of unknown substances. Like you are given some unknown substances, then you have to identify that given salt. That process, that analysis, the steps we follow in that analysis is known as the qualitative analysis. And when it involves the determination of composition of a mixture. You are given a mixture of salts and then you are identifying the composition of the different elements present in that particular mixture. That analysis is known as quantitative analysis. And to carry out this qualitative analysis, we take the help of reagents. So reagents are the substances that reacts with another substance and these are used in the laboratories, and the most important laboratory reagent we use is alkalis. And when these alkalis are added to certain salts, like any salt, as I discussed earlier, many salts we will do, when we will add these alkalis to the salts, these salts give characteristics precipitate of metallic hydroxide form. As I said earlier, when a salt, any metallic salt any metallic salt when react with the alkali, it will give metallic hydroxide. It will form metallic hydroxide and there will be a particular color or particular precipitate. This is what we are going to discuss in this chapter, and hence the metallic ion or metal ion is identified by this process, and we are using the reagents. In this chapter we will use two reagents. One is sodium hydroxide and second is ammonium hydroxide. As you know, in our periodic table, salts of representative element. You know what are the representative elements? These are present in group 1, 2, 13 or 17. And the salts of all these representative elements are colorless, whereas salts of transition elements, and the transition elements are present in the periodic table in the group 3 to 12. And the salts of all these transition elements are generally colored. So, let me show you the examples of colored and colorless ions. The colored ions are like ammonium ion, sodium ion, potassium ion, calcium ion, magnesium ion, aluminium ion, lead ion, zinc ion. So these are the cations which are colorless. So these are the cations which are colorless. Similarly, there are colored ions or cations like cupric ion, which is of blue color, ferrous sulfate, which is of light green color, and ferric ion, which is of yellowish brown. So also we are having anions which are colorless like chloride ion, sulfate ion, carbonate ion and nitrate ion. Many others are there, but I am taking few examples. Similarly, colored anions are permanganate, that is MnO4, which is pink or purple color, dichromate, that is Cr2O7, 2 negative, that is of orange color, then chromate ion, Cr O4, 2 negative, that is yellow color. Student, this chapter is practical concept. Not forget to learn your conscience book chapter 13, page 233. It is very important chapter because this chapter is related to practical work, and the questions from these chapters will be asked on the basis of the practical work only. So make sure you have to learn your chapter 13 also. So don't neglect this chapter 13, that is page number 233. Now for qualitative analysis. You know, qualitative analysis is for the unknown salt. So here we are taking solution of metallic salt, that is unknown metallic salt solution, and we will add alkali. What we will add? Alkali. First we will add it drop by drop. Here we will take alkali, sodium hydroxide, that is NaOH. And the product formed will be metallic hydroxide plus we will get salt solution also. And this metallic hydroxide which will be formed, it will be precipitated metallic hydroxide. It will be precipitated metallic hydroxide, and this color of this precipitate help us to identify the metal ion. And some of the metallic hydroxide which get dissolved in excess of sodium hydroxide to give a soluble compound. Let me show you how. Here we are taking the example of calcium salt. As I said, a metallic salt. This is here I am telling you this is a calcium salt. Suppose in the you are in the laboratory, you are given a unknown salt, then how you will identify? Presently I am giving you the example of calcium salt, and we are taking the calcium nitrate. Which salt we are taking? Calcium nitrate, and it is a colorless salt. When alkali, that is sodium hydroxide, is added, which is also known as a caustic soda, and the color of this alkali is also colorless, and we are adding it drop by drop. So what is the product formed here? So pay attention. The product formed is a metallic hydroxide, that is calcium hydroxide will formed, which is of white color. that is white precipitate of calcium hydroxide will formed. Also we will get sodium nitrate, which is a colorless salt solution. So the final reaction I am repeating, when calcium nitrate, the salt of calcium, reacts with sodium hydroxide or alkali, it gives precipitated metallic hydroxide, that is white precipitate of calcium hydroxide form, and also sodium nitrate solution formed. As I said, we added this sodium hydroxide drop by drop, but if this is added in excess, this white PPT which is formed, it gets sparingly soluble in the solution. When this sodium hydroxide is added in excess, this white PPT which is formed, it gets sparingly soluble. Another example I am taking here is copper sulfate, which is of blue color, and when this alkali, that is colorless sodium hydroxide, is added, we get metallic hydroxide, that is precipitated metallic hydroxide, that is copper hydroxide, which is of pale blue color, and also the salt solution which is colorless, that is sodium sulfate. When this sodium hydroxide is added in excess, what will happen? This pale blue precipitate is insoluble in excess of NaOH. So you have to learn all these reactions. What is happening when this sodium hydroxide is added drop by drop to the solution, salt solution, and when it is added to the excess. For different salts you have to learn. Similarly, from your book, page number 65, many other salts are given like iron, zinc, lead and ammonium salts. So you have to practice all these equations. On page 66 also, similar reactions are done with ammonium hydroxide, that is NH4OH. Here I have shown the examples with sodium hydroxide. On page 66 you will see the same equations are done with ammonium hydroxide. So you need to learn the complete table, all the reactions with colors of salt solution and the precipitated hydroxide formed. You have to learn all the colors of the salts and the precipitated hydroxide forms. You have to learn the proper colors and what happens when it is added drop by drop and when it is added in excess. So both the alkalis you will learn, that is sodium hydroxide and the ammonium hydroxide. But make sure learn the balanced equation. You have to learn the balanced equation. So do the practice of proper balanced equation in writing. Don't neglect it, because you will get marks only when the equation is properly balanced. So make sure you have to learn the proper balanced equation. So do utilize your time in a best way. Practice all these equations. Write it in your notebook. In this same chapter 4, now we will do action of alkalis on certain metals. Which all metals we are going to take? Zinc, aluminium and lead. And alkalis we are going to add is sodium hydroxide and potassium hydroxide. So let me show you the example. We are taking metal zinc and alkali we are going to add is sodium hydroxide and it is hot and concentrated. Make sure this alkali is hot and concentrated. When this hot concentrated alkali sodium hydroxide is added to zinc, we get product formed is sodium zincate, that is Na2ZnO2. Learn these formula very carefully. It is very important reaction I am telling you here. When zinc react with hot and concentrated sodium hydroxide, it forms sodium zincate, which is colorless, and hydrogen gas also releases. Similarly, when this alkali, now another alkali I am taking, now I am adding boiling caustic solution to aluminium. I am adding the boiling caustic solution, that is QH, it is boiling caustic solution, adding to the aluminium, and the product formed is potassium meta-aluminate. Learn this formula very carefully. Potassium meta-aluminate, that is K, potassium meta-aluminate, KaLO2, along with the 3 molecules of the hydrogen. So this is the action of alkali on certain metals. Now I am taking action of alkalis on metal oxide. Here I did action of alkalis on metals. Now the action of alkalis on metal oxide. Now some oxides of most atoms are, basic in nature. Basic in nature means they dissolve in water. When they dissolve in water, it forms hydroxide. Again, hydroxide is alkali. And these metal oxide and hydroxides neutralize acids, but do not react with the base. I am telling you, oxides of metal, which is basic in nature, when dissolved in water, forming hydroxide, and these metal oxide and the hydroxide neutralize acids, but do not react with the base. Let me show you the example. That is, I am taking sodium oxide, a metal oxide which is basic in nature. When it is dissolved in water, it forms sodium hydroxide, which is also an alkali. Now, sodium oxide, when it reacts with acid, it forms salt and water. And when this sodium hydroxide reacts with acid, that is hydrochloric acid, again it forms salt and water. So I have given the example when alkali react with metal oxides. Now there are few metallic oxides or hydroxides which exhibit dual character. Dual character means they show acidic as well as basic in nature. They are said to be amphoteric. In nature. And amphoteric compounds which reacts with both acid and alkalis. When it reacts with both acid and alkalis, it forms salt and water. Let me show you. Here I am taking the example of amphoteric oxide, that is zinc oxide. This is a metallic oxide, but it is an amphoteric oxide. It reacts with acid, it forms salt and water. Same oxide when react with alkali, that is first reaction is with the acid, second reaction is with the base. Again it forms salt and water. Make sure whenever you are learning the equation, it should be properly balanced and chemically written correctly. All the symbols should be written correctly. And these equations are given on page number 68. I have given you one example. Other examples are also there. You have to learn it from your book, that is oxides of aluminium and lead oxides. So two more examples you have to learn from your book is oxides of aluminium and lead also. Any doubt related to this chapter, if there is there, this chapter is actually very easy. Only the thing is you have to practice it. You have to write the equation. Don't neglect it. And nowadays you are sitting free only. So use this precious time. So don't waste your time. Books are your best friend, as I said earlier. So go through your books, read it thoroughly and practice the equations. You can't learn chemistry without practicing the equations. You have to learn the equations thoroughly. And if any doubt is there, please comment me and I will reply you. So, all the best.